Hi, I'm Don Sackett, CEO, co-founder of SciApps, and we're here to talk about this great new LIBS product, the Z-70. LIBS has been around for roughly 10 years now, and a lot of the early LIBS had all this promise about replacing handheld XRF because it was fast, it could do all the light elements like the aluminum alloys. It was no regulation because no X-ray, all these great things. But over the years, a lot of those LIBS products didn't live up to the promise of what everybody had hoped. But now I think finally there is a LIBS out here that does all those great things. This is the Z-70, and we've just brought it out about 3 or 4 months ago, and we're really excited about this because this is like the sort of basic, really easy to use metal sorting tool. Whether you're doing scrap or you're a fabricator, you want to make sure you haven't mixed up your raw materials. It's a great analyzer. I'm going to take you through it real quick. First of all, you see it's really easy to turn on and fire up. Once you turn it on, it comes up to its temperature. You hit analyze. You do a wavelength calibration. That's all it takes is right there, and now you're good to go. So the first thing I want to point out about this analyzer is it's got a much more powerful laser in it than the early LIBS that were put out by some of the other manufacturers. And that's really important because it burns through surface material, dirt. In the case of aluminum, it burns through the anodizing. And that's great because it makes it easier to use. Your operators don't have to wonder, do I grind, do I not grind? They can just shoot stuff and test it. And that's really a key to, I think, a simplistic operation that's also fast. So let's do the easy stuff first. We'll take a bunch of standards here. I know anybody can shoot standards, but let's just start it with this. So a couple of seconds, there's your 60-61. Let's just keep going through here. All right, that was your 60-61. Here's a 60-63. Couple of seconds, here's your 63. And this thing will just blow through all these simple aluminums. And we'll go to the real stuff in a second. I just want to show you how quick this is. There's your 2024. What's this one? It's just here's your 70-55. Anyway, you get the idea. It's really easy. Now let's go to the real world because that's really what people test. They don't sit around and test standards all day long. So let's take some real aluminum. First of all, we'll go to the other bases in a minute, but real aluminum. So you can see this. It's probably got an anodizing coating. This is unground as is. It's a little dirty. You can see my hands are getting dirty, but you just shoot that. And there's your 50-52, almost a perfect match. Let's go over here to this thin little piece. I think this is an 1100. We'll know for sure in a second. Yeah, there's your 1100. This is a good one to do. There's your 1100. Again, take it to the real world. There are ground spots, but I'm not testing those. I'm testing where this anodized. This should be a 60-63. So see how quick that is to do 60-63 and 1100. Those get mixed up a lot especially by some of the older XRFs, not ours, because you got to be able to see the magnesium quickly to separate those two. Anyway, that's kind of how the LIBS goes, and you don't need to grind it. One of the other neat things about this, there's another 63, is it's got a nice safety feature. That even though it's a 3B laser, you can operate this as what's called under Class 1 conditions. And the reason for that is because if I just try to shoot this thing into the air, it won't fire. It just says no sample detected. It won't even fire the laser. So because of that safety feature, which we patented, as an operator, you can actually operate as a Class 1 device. Anyway, let's go on to some other bases real quick. This has got aluminum base. It comes with 7 bases: aluminum, titanium, magnesium, nickel stainless, copper, and I think that's it. I think cobalt. And you can also add bases if you want, but we generally ship the units with those 7 bases. So let's take this piece. I don't know what this is. There's a 304. Okay, that's an easy one. Let's shoot this guy. This is some sort of probably a high nickel alloy. It's a turbine blade. The other neat thing to see is it's got a nice internal camera, so you can actually and you see the white dot where the laser's going to hit, so you can make sure this thing is lined up and it's on the sample. And there's your MAR M247 with a really good match, almost a perfect match. The other thing to notice when I was doing this, I'm holding these things in my hand, right? You're not supposed to do that with XRF. People do it, but they shouldn't. But I've been holding these in my hand, I've been shooting them, and there's just no safety concerns at all with the laser system doing that. All right, that was a high nickel. Let's see what this is. Again, kind of dirty, got a coating. This LIBS doesn't care, it burns right through it. That's a 7030 Cooper nickel. Now, one of the questions I get, let's check out this guy. Here's another turbine blade. Let's see what this is. Udamet 500. Yep, that's what that is. So you get the idea how quick and easy this is just to go through all your material. Here's a nice dirty piece of metal. Let's check this out. What's this guy? 6246 titanium. Now, the question I also get is, what happens if I just test some piece of metal, I have no idea what it is? What if it's not one of the 7 base metals with all its alloys that's programmed into this device? So let's do that. This is a piece of just pure moly. So if I shoot pure moly, even though I don't have that base in here, it just calls it a moly-based alloy. So if you do need to start identifying molybdenum alloys, you can add them into the software, then you can also sort those. But it won't give you the wrong answer if you don't have that base there. Another good example is this guy. This is a really oddball one. This is a CB103, but it says it's a columbium alloy or niobium-based alloy, so it says it's niobium-based. If you need to add it, you can do it. Other analyzers, you have to send them back to the factory. This one, you can just add those grays right in. A couple other things to note about the Z-70. First of all, we've really eliminated the drift correction. Now, some of the older LIBS models, you had to drift correct sometimes multiple times a day. We've stabilized the laser temperature with a new method, and you don't have to do that at all. And as you might have watched, I turned it on, we started shooting, we didn't do any drift correction, we got good answers, we got good results. So another benefit is no drift correction. Let's just do this. You hear that noise? It's not just a laser, there's a fan in there that runs, and that fan is blowing air out through here, so it's blowing any of the ablated material out of the analyzer, so it's not accumulating on the optics. So that gives you, even in a sort of with a lot of dirty or oily samples, you're not going to be contaminating your optics, which means lower maintenance, no drift correction, and just good, stable operation, right? So that's really how the device works. It's fast, it's easy, does all your bases, it's repeatable, very safe, and you've got a lot of nice features on here, like the internal camera. It's cloud-based, so if you want to just download everything to the cloud, you can. You don't have to be printing out Excel spreadsheets. And it's a great system, and it's priced really competitively. And I think it's a great tool for just fast alloy sorting, whether you're a smaller recycler or you're a fab shop and you need to know what your metal is.